Right, so we have finished with the geometry, and now we have finished with the mesh, and now let's go to the third part, which is now setting up the work in Fluent. So we double click on setup. It takes us to a very default page. It just says whether you want double precision or not. Yes, absolutely. And it asks for your processing options. Now usually series means that you are using one CPU power for your work. Parallel means if you want to use parallel CPUs. Now please note that if you are using parallel computing, that would mean that a lot of your CPU power is going only towards your simulation, so you would not be able to browse and do other things on the side. So I would recommend only to use parallel processing when your CPU is completely free, i.e. you do not want to use it only apart for simulation, or when your CPU is very high performance, because it is true that parallel processing will make your simulations happen quicker, but that would also mean that you would not be able to use anything on the side. And for a very simple simulation like this, series processing is much better. So let's go with series. So we click OK, and now it takes us to the setup page. Setup is where we are setting up our simulation for modeling. We have meshed it, and now we want to set it up. So it takes us to a page which is filled with options. Now I don't want you to get confused. That is why I would only take you through the options that are needed for your simulation rather than take you through all of them, because there are a lot of these which we don't need, and there are a few that we actually need. So this is where you get your model. If you want to see how it looks like, we see the last toolbar here which says front face transparent. If you click on this one, we can actually see how your model looks like. The toggle bar here, so the option is to rotate. By clicking, you can rotate your model. So you can see here we have a surface in blue, we have a surface in red, and then we've got surfaces in yellow. What this indicates is that the CFD has identified your inlet and gives it a color blue, code blue. It has identified your outlet, gives it a code red, and all the other options like symmetry and the circle wall, etc., are all given a code yellow. So that is quite good, because it sets us that what we've been doing, the named selections are fine. Some options here: if you want your simulation to be steady state, by default it is steady. If you want it to be time based, then we can select the option of transient. Since we do not want this to be time based, we would go with an option of steady. The rest of these can be left as default, they don't need to be tinkered with. If you want to specify gravity, you can. So if you want it to be more realistic, if in the XYZ coordinate x points up, that means gravity would be minus x in the downward direction. So minus x can be set as your gravity, 9.81 or 10, depending on whatever value you want to put. Again, you can recheck your units. So if I click on the units from this bar, I can check my units for different parameters. Most of these would be fine because we selected metric units at the start, so that technically means that all of our units will already be metric, so that's fine. For temperature, since the metric unit is Kelvin, if you want to change that to degrees Celsius, then from Kelvin we can change it to degrees Celsius, and you can click C and close. Right, so the important toolbar here is the one on the left, the setup, solution, results. Setup is where you set your geometry, solution is when it does the iterations, and results is the one where we are able to view results. So let's go through the setup one by one. Let's start with the models. So if I double click on models, it takes me through a list of different models. Now you have to remember that different models are used for different purposes. So if our purpose here is only to simulate airflow around an object, then we do not need a lot of these models. The ones we need are energy and viscous. And let me go through these. So viscous means how your airflow must be. At the moment, it is by default current set to laminar, which is an ideal case scenario if you want your flow to be laminar. But in real life situation, we know the flow is not usually laminar, it is turbulent. So therefore, if you double click on viscous, it takes you to all the models that are associated with fluid flow. Inviscid, laminar, K epsilon, K omega, etc. The most common model used for turbulent equations is the K epsilon model, which is called turbulent kinetic energy, which is the K, and turbulent dissipation rate, which is the epsilon, the KE model. This is an equation which is inbuilt into the algorithm which simulates pressure and velocity based on a turbulent scenario. Now there are governing equations behind it, and all of the model constants are provided here. My best advice in this case is to do a bit of literature research on which model is more suitable to the type of application you are wanting to simulate. But with most models, or the most common model that is used for simulating air movement, is the K epsilon model. I wouldn't worry too much about the different options here. Yes, you can look into them, you can do a literature review, or you can do research around what these different parameters mean. But for getting a reasonably accurate result for a conceptual design, the K epsilon standard model with standard wall functions is a good start. So we would select the K epsilon model. I'll click OK here. So that sets up my turbulent model, and the energy is if you want to set your temperature. So if you want to set temperatures to the inlet and outlet, and you want to see how the temperature will affect your flow, so we can turn the energy equation on just by clicking on it. So now this means I can apply temperature to any part of my model. Other models are used for other purposes. Multiphase is used for mixing liquids. So if you're working with chemicals and you want multiple liquids to work with, then we select the multiphase model. If you are looking to work with humidity and you want to set up water vapor and water liquid, then again you can work with multiphase model. In this stage, since we just need air, or we just need a single fluid, the multiphase model can be turned off. Similarly, radiation and heat exchanger, if you are working with solar radiation or conduction and convection principles, then you can select these models. And then you've got acoustics and structures and other models depending on what they are used for, very specific purposes. But for us, or for this case, we are going with the very basics of how to govern airflow around a circular body. So we just really need the temperature and we need the airflow. So once we're done with the models, we go to third part, which is materials. There are two types of materials in CFD. One is solid and one is fluid. By default, ANSYS sets up air as the fluid and solid as aluminum. If you want to change it, you can. So if you want to change aluminum to a different material, if you want your circle to be made out of steel and not aluminum, then that can be changed. You would select aluminum, you would go to create and edit, and it will take you to a toolbar. This is quite good because it gives different properties surrounding for different materials. And if you want to now not select aluminum and select something else, you would go to Fluent database. It takes you to the Fluent database, and we want to select a solid material, so I will change fluid to a solid. And now it gives me different list of materials to what I can use. Copper gives me its properties, wood properties, steel properties as well. So depending on which material I want to use. So if I am just looking to use steel, I would click unselect copper and only select steel and click copy and click close. So now I can see aluminum and steel appearing in my database. And if I want to go ahead with steel, I would click steel and say change create. And then if I close this, now you can see both steel and aluminum appearing in the model. So depending on which one you want to use, you can use that. As a general rule of thumb, when we are simulating airflow around a body, any circular or any any geometry for that matter, the solid part of the body doesn't really matter. I would be more concerned about whether my fluid side of things are correct. So I would definitely want this to be air because I want to simulate air. Whether my circular disc is made of steel or aluminum, it will not have a huge effect on the simulation. So I would not be very picky in terms of what solid objects I would select. I would just go with the one that's nearest to my offering. But for fluid, I would ensure that this is air because that is what I need. So that is air, that is good. Materials done. Moving on to the third part, cell zone conditions. This technically means how many bodies we have in the model. So currently we've got two cell zone conditions. The first one is a solid. This technically means is our circular disc. And then the other one is a fluid solid interaction. So that is the environment around it. So this tells me that in my model, the ANSYS Fluent is looking at it from a wide angle view where it has a circular disc as a solid body, and the interface around it is made up of air, which is a fluid, and it is interacting with this solid. So my cell zone conditions are good. Moving on to the most important part, which is the boundary conditions, and that is the importance of creating your named selection, because when you create a named selection, you can actually see it in the list, inlet and outlet. So I can then select my inlet and outlet parameters. So if I go to inlet and if I go to edit, I am now asked to set a velocity or set a speed. Currently by default set to 0. So if I say I want the airflow to come in at 4 meters per second, so I can select that. There are different ways in which I can simulate airflow. The default one is normal to boundary, which is the most simplest one. Normal to boundary means that if this is your inlet surface, your airflow will always be perpendicular to it. So air will always move in the direction of the flow. You can also set your airflow by coordinates. If you do not want your airflow to be perfectly perpendicular, and if you want it to be more natural where it is probably flowing down or flowing towards the ground, then you can say magnitude and direction. Once you click magnitude and direction, it takes you to the XYZ coordinates, which is your XYZ on your bar here, and you can select the direction in which you want your airflow to go. But for a very simple scenario, we can just click normal to boundary, and this will ensure that all of my airflow is normal to the boundary, which means it is perpendicular to the surface and goes straight to my circular disc. You can also set up turbulence. So by default, the ANSYS suggests me that the turbulent intensity must be 5%. If you want your airflow to be more turbulent, you can make it 50%, or you can make it 100% to be very turbulent flow. I would usually just like to go with the default setting unless you have genuine reasons to change it. So I would probably just select the default as 5%. So here is where I set up my airflow. Under the thermal tab, I can select the temperature. So the default temperature at the moment is 26. If I want to select a temperature of air 30 degrees, so that I can select 30 here, and now it would say that my air will come in at 4 meters per second and will carry a temperature of 30 degrees. So this is where I've set my inlet.